Hello everyone, my name is Xuanze Zhong. Today I'm going to talk about my research proposal, which is the indirect method of measuring biomass production on faba bean Vixia faba through imagery. The outline will be divided into five parts, which are introduction, aims, research plan, expect outcomes, and the timeline. First, I'm going to give you the introduction of the research. As you can see in the left top corner, there is a picture of faba bean. Faba bean is a globally important cool season legume crop, which can be used to satisfy human consumption, animal feed and protein, and diet fiber. Moreover, it can be improve the rotation sustainability of cropping systems through nitrogen fixation and disease cycle break. From the FAO database, the global average yield of faba bean is only 1.8 tons per hectare between 2012 and 2014. While the average of yield faba bean in different regions has obvious gap, as we all know, achieving higher yield is the alternate game of any crop breeding program. Therefore, it's important to know the biomass production is directly correlated to grain yield. This page shows the evidence of feasibility that the biomass production is directly correlated with grain yield. Based on previous research, the amount of biomass production provides a good indication of final seed yield. Moreover, Atomedy mentioned one of the faba bean with the highest biomass also produced a maximum seed yield. Another thing is that conventional method of biomass measurement is time-consuming and destructive. For more details, the conventional method involves cutting whole plants from a portion of a plot and driving it up to carting. Therefore, an alternative non-destructive method is needed to save both time and cost. The Canopy app could be an efficient method that uses RGB color system to estimate biomass production. It can be directly get the percentage of green color without the removal of soil, vegetation, and deionization. It turns plant green pigment to white without simple adjustments, and produce white pixels on the picture by in digital imagery. The total biomass can be estimated by counting the pixel in the background, which is alternated by the app. Canopy also has field use advantages, which will not be easily affected by the background. More importantly, it is non-destructive and reliable, and it has been successful used biomass production on other crops. Therefore, it is reasonable to be used in this experiment. Let's move to the aim part. The main aim of the research is to find an indirect, efficient, cost-effective, practical, and non-destructive method, and it will investigate whether Canopy can be used to measure the faba bean biomass through imagery, which is a non-destructive method. Another aim is to find the correlation between biomass and crop growth rate. And the hypothesis is that Canopy can provide a good estimate of biomass production in faba bean by comparing growth rate at different intervals, and this method can be used as high throughput phenotyping method in identifying high yield breeding lines in a breeding program. The following part is research plan. The Canopy app is designed to estimate early vigor and biomass production on faba bean. The experiment will consist of 32 lines for faba bean from an existing S4 faba bean trail planted by the breeding team at the University of Sydney Plant Breeding Institute. The experimental results from the trial site will be used for identifying high-yielding fiber bean lines. This page is to give you more information about canopy. The bottom right corner is an example of canopy pictures. Canopy cover from the mobile phone range from 0 to 1, where 0 represents no green canopy, and the value of 1 means 100% green canopy. Therefore, the canopy cover is usually recorded in percentage, and its instrument cost. The only technical instrument required is a mobile phone with the Canopy app. Thus, it may reduce experimental cost, which is friendly to people who don't have enough funds for experiments. The experiment will be conducted in a randomized complete block design with 3 replicates, and the plot size is 12 times 2 meters. 22 seeds per square meter will be planted with a tin seeder with a target of at least 20 plants established. More importantly, weekly crop monitoring should be done to avoid fungal disease and insects and pests. To prevent any crop damage, the most important part in the exam is to take digital photos of each plot and record the crop height for 5 weeks by using smartphone and a ruler. Especially as you can see the picture, I try to create a model. The plant height will be measured with a ruler from the base of the plant to the highest point in the plant in 3 random points per plot. This measurement will be taken every week after a month of normal sowing for 5 weeks. Moreover, the research plan also includes the following parts. To reduce errors in the experiment, we may need to keep our smartphone camera still at the same distance, and the time intervals should be the same as well. When it comes to data processing stage, all data will be used for the analysis during the experiment. Bayesian multiple variate fixed model will be used in the experiment, and this data should be evenly distributed on both sides of the regression line. The final research plan part is that the correlation of canopy cover and plant height will be used to derive biomass and crop growth rate. When we move to expected outcome, indirect method of measuring biomass production will be useful not only for soybean but also for any other crops. Compared with the conventional method of biomass measurement, it is also useful in breeding programs to screen a large number of breeding lines for higher yield. In particular, broader green cover with more height on being in the same interval can be expected. It is also beneficial for each country to get more food supply and develop more comprehensive cropping systems. In addition, breeders can use the same way to estimate biomass production of their crops that is suitable for their regions due to the fact that key crop traits follow a common, relatively stable and developmental system. To sum up, indirect method of measuring biomass production is a fast, cost-saving, and reliable way that can bring benefits globally. The timeline can be divided into 5 stages. Normal sowing will be the beginning part, which will last for a month. Both plant height record and canopy photo taking start at the same time, which will span for 5 weeks, and the following parts are data collection and analysis, and the write-up session. Each date and indication of completion is vividly written on the table. Here are my references. There are 4 pages. Thanks for the help from my supervisor.